So in this video, we're going to be looking at a whole bunch of transformations. You'll see in the left-hand corner this highlighted in red. This thing is your shifts, your slides up, down, left, and right. So the way that you figure out which direction it's going to go, it's always going to be a number added or subtracted, and then it's going to be, if it's inside the function, it'll go left and right. If it's outside of the function, it will go up and down. So depending on whether it's plus or minus tells you which direction it'll go. The second type of transformations are dilations, is what you'll hear them called, and that means they're getting fatter or skinnier. And so depending on where the number is located tells you what kind of shrink or stretch it's going to be. So you'll see these are always numbers that are being multiplied. So anytime you have a number out front being multiplied, that is going to be a dilation of some type. If it's inside the function, meaning it is contained in the parentheses, in the absolute value bars, in the square root, that is going to be your horizontal stretches and shrinks. So if it's between 0 and 1, most of the time a fraction, 1/2, 1/3, 1/5, 0.05, all of those are between 0 and 1, it's going to be a horizontal stretch. If it is going to be bigger than 1, it's going to be a horizontal shrink. And again, that is all the time that it's happening inside the function. The other option is to be outside the function. So you'll see that the C is out front of the function, meaning it is removed from the square root, it's removed from the parentheses squaring, it's removed from the absolute value bars. If it's between 0 and 1, it's a shrink, vertical shrink. If it's bigger than 1, it's a vertical stretch. Your last option is if you have a negative sign. So the negative sign acts independently of the number that it's connected to. So if you have a negative sign out front, way out front, if it's inside the function, it goes over the x-axis. If it's outside the function, it goes over the x-axis. If it's inside the function, it goes over the y-axis. So we're going to take all of this, combine it with our knowledge of parent functions, and then work on graphing these using the transformations. So here you'll see, here are my parent functions that you need to know. You need to know the ones that are highlighted in blue. So the identity function, absolute value function, square root function, squaring function or quadratic, cubing function or cubic. You need to know those 5. You also should know these red dots that I have placed on the graphs. You need to know those because when we talk about moving things up, down, left, and right, well, you need to know what you are moving. So I went through, and you may want to add these on your notes, I went through and I added the dots on my graph, and you should do the same with yours to make sure that you have the appropriate dots that you're moving. Alright, so here's my first example. It is number 10 in your textbook, in the new 7th edition textbook. So I have y1 is x cubed, y2 is x cubed plus 4, and y3 is x cubed minus 4. Now what the y1, the y2, the y3, that just means this is the first function, this is the second function, this is the third function. That is all it means there. And the directions tell you to use transformations to graph those 3 equations on one graph. Now if you want to in your notes, if you want to graph them all 3 separately, that is fine. I'm going to put them all on one graph just to save space. So the first thing I always do is I find the parent function and then I list off the transformations. That helps me graph these a lot better than if I just try and do it all in my head. So you'll notice this first one, which I'm going to graph in red, x cubed. That is the parent function. And if you remember previously in the video, we said that the points were always 0, 0, 1, 1, negative 1, negative 1. So that is your parent function. You do need to know those points. It's going to help you move the graph around a lot better if you have some points to move. So that's the parent function, x cubed. You need to know that. The second one says, we'll take the x cubed function and add 4. So we'll do this one in blue. A plus 4 outside of the function means that I'm going to go up 4 units. Well, take what up 4 units? Every single point on the graph. So here I have 3 points. I'm going to move this point up 1, 2, 3, 4. Put a dot. I'm going to move this point up 1, 2, 3, 4. Put a dot. And then I'm going to move this one up 1, 2, 3, 4. And put a dot. Now I connect it up. Okay, so there's my second graph. My third one says x cubed minus 4. So we'll do this one in green. So x cubed minus 4, that 4 is being subtracted. It is outside the function. So it's going to go down 4 units, which means I'm going to take every single point in my parent function. This is my parent function, the red graph. I'm going to take every single point and move it down 4. So I'll be here and I'll go 1, 2, 3, 4. And then I have the next one down 1, 2, 3, 4. And the next one down 1, 2, 3, 4. So every single one of those points, I moved it down 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And now I'm going to connect them with my curve. So there are your 3 graphs. Again, you are always graphing from the parent function. And the parent function is the x, and in this case, the cubed, or the x and the absolute values, or whatever the case may be. All right, the next example, this is similar to number 17 in the textbook. I changed around a little bit because I wanted it to look slightly different. So the first one you have is y equals absolute value of x, and then y2 is negative 4, absolute value of x plus 4, and then y3 is absolute value of x plus 1 minus 2. Okay, so we're going to do the first one first. We'll do that one in red. So that is my parent function. Y equals absolute value of x. It always goes through 0, 0, 1, 1, negative 1, positive 1. Absolute value always has the V shape. Absolute value starts with a V, so you can remember that it makes a V. Now those are the points that I'm going to move. So this first one we'll do in blue has a lot of transformations. Now this part is not a transformation. That all just tells you that is the absolute value parent. It's like the last name. It tells you which parent it belongs to. The rest of the stuff is how it's different. So the first thing I have is this negative sign. The negative out front is a reflection over the x-axis because it's outside the function. That 4 is going to be a vertical stretch because that 4 is a number being multiplied and it is outside the function. It's bigger than 1, so it's a vertical stretch. And then the last one I have, plus 1 inside the function. It's a number being added or subtracted inside the function, and it is going to move it left 1. So the way I graph these, I take the parent function and I move the points the same order. So I'd reflect them first, I'd stretch them, and then I would move them to the left. Okay, so which points? Well, it's the point that are on the parent function, or the points that are on red. So I'm going to reflect it, so that means all of these points are going to reflect over the x-axis. So this point is going to come down, this point's going to come down. That middle point, the origin's not going to change because I'm reflecting over this. So here's my reflection. Now I want to make it narrower. So before I went down 1 over 1, right here, or up 1 over 1, up 1 over 1, because there's a 1 in front of that. Here, there's a 4 out front, so I'm going to go down 4 over 1, down 4 over 1. So notice here's my next graph. So I'm taking this into pieces. Now I'm going to take that thing and I'm going to shift it to the left. So every point is going to go to the left one. So I'm going to erase all this other stuff. Clean this up a little bit. And then I'm going to draw my new graph. And so you'll notice it is skinnier than the parent function, shifted to the left, and it's flipped upside down. Alright, my last one, which I'm going to do in green, doesn't have anything out front, and remember the absolute value bars in the x just tell me whose parent it is. Plus 1 inside the function was the same as before. It's going to move it left 1. And then the minus 2 outside the function is going to move it down 2. So I'm going to take all the points on the red graph and move them left 1, down 2. So I'm going to go left 1, down 2, left 1, down 2, left 1, down 2. And I'm going to plot all of these new points. And so there is my new graph. So those three are your graphs all graphed onto one. Now if you want to split them up and graph them on 3 different coordinates, that's completely fine. Alright, example 3. So this is similar. This is question, well, I don't have access to it, but this is one of the questions in your textbook, and for whatever reason I didn't write it down. So the way that I handle these is I look at the actual graph they're giving me. So here's the thing that they want me to change. Here's what all these sentences reflect, that graph right there. So I ignore all those words first. The first thing that I'm going to do is I'm going to write that graph down in my notebook or in my homework or on the test or whatever, and I'm going to list off all the transformations. And then I'm going to go back and try and fill in the blanks. So the negative out front, remember the negative and the number act separately. The negative out front is going to be a reflection. And it's going to go over the x-axis. The number out front, that thing is going to act separate. So that acts. That acts. The 2 over 5 is a number out front. It's being multiplied. It's between 0 and 1. So it's going to be a vertical shrink. And then now I have another negative sign inside. So then I have that thing. Negative sign inside the function is going to reflect over the y-axis. And then the last thing I have is this plus 6, which is going to go up 6 units. So now that I've kind of gotten an idea of what the function's doing, now I can go back and piece in the directions. So it says, the graph of y equals negative 2 over 5, absolute value of negative x plus 6, can be obtained from the graph y absolute value of x. That's just telling me here is your parent function, here's your transformed function. So now start filling in the blanks. By reflecting across the blank axis, so I'm just working in order. So the first one was by reflecting across the x-axis, what I wrote down below. Vertically shrinking by applying a factor of blank. So we saw right here that the 2 over 5 was what gave me the vertical shrink. So it's going to be a reflection of, it's going to be a vertical shrink by a factor of 2 over 5. Then it's going to reflect across the blank axis. Well, that's the next one. So this negative x inside the function reflected over the y-axis. And then shifting vertically 6 units in the up direction. So it just works from left to right. and kind of makes you break down piece by piece all the transformations. Here's my last example. So this is how it's tying all together. It wants you to use transformations in a parent function to graph that thing without going through your calculator, because you're going to run out of time on the test anyway. So the first thing I always write down is the parent function, and I list off the transformations. So in this case, the parent function is the square root of x. Everything else is a transformation. So my parent function is the square root. Now my transformations, I just start on the left side and I work across. So a 2 out front, all the way out front, it's being multiplied, it's outside the function, it's bigger than 1, so it is going to be a vertical stretch. And then still working on, let's label that, -2 inside the function, so that's x minus 2, so it's inside the function, it's being subtracted, so it's going to move it right 2. And then the last one, -1, so I'm outside the function, subtracting 1, so it's going to move it down 1. So now I'm going to put all of those transformations together and move the parent function graph. So it helps to plot the parent function. Square root function goes through 0, 0, 1, 1, and I'm good if you just know those 2 points. So here's my parent. Now I want to move the parent, the transformations that are in blue, the transformations up above. So I want to stretch it up. So this thing, 0 is not going to change. This point is going to get stretched up, and instead of being 1, it got stretched up by a factor of 2, so I multiplied it by 2. So it got stretched up to a 2, and then all these points are going to move to the right. So it's going to go right 2, 1, 2, put a dot, and right 2, put a dot. So here's my graph. So I'm steady moving this graph. Now I'm going to move them all down 1. So this is going to go down 1, and then this one's going to go down 1. And so here is my new function. And that combined a whole bunch. But if you take it part by part, start with the parent function, know 2 to 3 points on every parent function, because it's going to help you when you're moving these things. It's going to help you know what to move. And then you're going to slide them in the direction. I always move from left to right. So I start with the parent, whatever transformations are on the left, and then I just gradually move across.